Hi, hello, I'm Sita Lakshmi, second MSc Biology. Today we're discussing about the topic Enema spectroscopy, neutron scattering and comparative modeling. Let's begin. Okay, Enema spectroscopy. It is also known as magnetic resonance spectroscopy, and it is the spectroscopic technique to observe the local magnetic field around atomic nuclei, which is based on the absorption of electromagnetic radiation in the radio frequency region at 4 to 900 megahertz by nuclei of the atom, and it is used to determine the structure of organic compounds. That are the NMR spectroscopy, and this is the working. How NMR spectroscopy is take place. All the electrons are charged. So when we produce an magnetic field, there is an electron spin take place. Then that leads to the lower energy level to the higher energy level. So there is an energy transfer take place between them that may be detected by the decay, and finally we get the NMR spectrum. That is the main functioning of NMR spectroscopy. Then the instrumentation. This is the sample tube, and the sample tube is and the sample tube, which is a glass tube, 8 centimeter long or 0.3 centimeter diameter. That is the sample tube, and the magnetic and permanent magnet are present, and which gives the magnetic field. Then the magnetic coils, which is induce the magnetic field when the current flow through them, and sweep generator are present. There are equal amount of magnetic field passes through the sample, and there is a transmitter and the detector. When the transmitter, which transmitter that produce a short powerful fluxes, that is the function of transmitter, and finally it detect by the detector, and they get the spectrum. That is the readout system. This is the readout system. Okay. Then and working. The sample is placed on the magnetic field. The NMR signal is produced by the excitation of nuclei. That is the energy transfer between the electrons. Then sample with the radio waves into the nuclear resonance, which is detected with the sensitive radio receiver. That are the working. And what is the application of NMR? NMR is used to study the physical and chemical and biological properties of matter, and an, 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 analytical chemistry technique used in the quality control, and used in the research determine the content and purity of the sample as well as its molecular structure, and replacing the XLO crystallography for the determination of protein structure. Then another one used to determine the molecular structure of solid, and next one used to probe molecular dynamics in a solution. These are the application of NMR spectroscopy. And the next topic is the neutron scattering, and the irregular dispersion of free neutrons by matter can refer to either the naturally occurring physical process itself, or to, the man-made experimental technique. Man-made experimental technique that are used in the new natural process for the investigation materials. So we can investigate materials. And neutron scattering involves the creating a beam of neutrons passing that the beam through a sample, and okay, and where the and noting where the neutrons scattered from the sample and hit by a detector. So here also used by a detector for detecting the neutron scattering. This is the incident beam, and this is a sample. Sample is placed and the incident beam is moved through that. It may be scattered, and which detector using to detect the neutron scattering. And the next modeling, comparative modeling, that is the protein production. And in more than 15 years old, protein structure production continued to be an active area of bioinformatics researchers, and now predict the 3D structure of protein using three methods: comparative modeling, threading modeling, and ab initio method. And I explain in this topic, that is the comparative modeling, that is the protein structure prediction, and it is also known as homology modeling, and it is the most powerful and accurate approach to the homology modeling. Homology modeling is the robust technique for protein based on the coordinate of non-homologous found in the PDB. PDB, which means the protein data bank. So here the coordinate is take place. Coordinate. Both the structures are coordinate. The quality of model strongly depends on the degree of similarity between the query sequence, which means the unknown protein sequence, and the matching database sequence with the protein sharing highest degree of similarity being molded best. And it is a multi-step process. They have several process. And the first one, sequence alignment, which means the align the unknown sequence, that is the query sequence, query protein sequence, to the sequence of non-structure. And structure modification, the deletion or insertion take place, adding of any like methylation or acetylation, that's mean insertion or deletion. And such methods are used to modify the structure. And the database searches. And the energy minimization, that means energy minimization, defining the model using energy minimization to relieve the collision or steric strains. And finally, the structure evaluation to generate a structure. Validity of the modeling and using visual inspection and get the image. And most commonly used freely available homology modeling package is Modeler. And Modeler is the oldest one and best known homology modeling package. It is used to use the method called satisfaction of spatial restraint. And it is a several variant include SA modeler, easy modeler. Okay, then that's enough, and thank you.